So, good afternoon, everyone, and welcome to ZEBx's Decarb Lunch series. My name is Natalie Douglas, and I'm the program manager for ZEBx, the Zero Emissions Building Exchange at the Zero Emissions Innovation Center. Today, we'll be hearing from my colleague, Stephanie Dallow, program manager at CLF-BC, and our resident circular strategies aficionado. I'm grateful to be joining you all today from the unceded traditional territory of the Musqueam, the Squamish, and the Tsleil-Waututh Nations. And I also want to give thanks to the City of Vancouver and North Family Foundation for their financial support that helps us offer these educational webinars completely free. So if you're interested in getting continuing education credits for attending today, please see the information that my colleague Anna is going to drop into the chat. I also encourage you to make comments or ask questions to the presenters or anyone else joining us today in the chat section. We'll be using those questions to help guide discussion near the end of the hour. My colleague Annie is also now going to launch the first poll to help us get a sense of who's attending here today. And with that, I'm going to pass things off to our wonderful co-host for today, Sheila Malloy, Executive Director of Coast Waste Management Association. She's going to tell us a little bit about CWMA and offer some thoughts about the importance of what Stephanie's going to be talking about. Over to you, Sheila.
Well, thanks so much, Natalie. And right, I am the ever proud Executive Director of the Coast Waste Management Association, who is actually celebrating 30 years of great work in 2025. And who we are is a community of industry leaders who come together just to share successes, discuss some of our challenges, build knowledge, and really compare on-the-ground experiences, all towards trying to look for the best solutions for managing and reducing solid waste across British Columbia. We are the largest industry-facing association in BC. And you will see information on the bottom, not as important as talking about today's topic. So my next slide kind of gives you a particularly meaningful look towards our industry. And this archive piece tells you a little bit about why it's important that we're all here today. And I'm so grateful to be incorporated into this great Lunch and Learn. So our industry works to increase diversion and reduce construction and demolition waste in landfills, which is one of the largest contributors of waste in this province at about 1/3 of all waste. So you can see from the spring of 1999 news archive that we have been trying to tackle this for a long time, and that the government in 1998 actually held a symposium with demolition contractors, municipal engineers, and permitting staff from a lot of municipalities, but was, I think, missing some key groups who are, I believe, in this room right now. And back then, maybe not as much of a focus on the circular economy. So it's events like these and people like Stephanie and all of the work at our, great hosts here that is super in setting the examples and gives us all hope in the waste industry that solutions are coming sooner. So with that, I mean, we're all here to listen to Stephanie, and so I'm really excited to bring her on board to make an introduction and get started on the presentation.
Thanks, Sheila. Thanks, Natalie. And thanks to everyone who made the effort to be a part of today's presentation and discussion. Okay, so today we're here to talk about the intersection of embodied carbon and circularity, or in other words, where embodied carbon meets circularity. And before I get started, I want to take a moment to acknowledge that I live, work, and play on the unceded and ancestral territories of the Squamish, Tsleil-Waututh, and Musqueam First Nations community, who have been stewards of these lands since time immemorial. And a lot of one thing I want to add to that is a lot of these concepts I think really align well with the 7 generations principles and that abundancy mindset. I think that we can learn a lot from the Indigenous and First Nations communities. And also these themes really mean that we have to sort of shift away from this system change and social innovation paradigms, thinking about systems change and social innovation paradigms and shifting away from a scarcity, urgency, and efficiency mindset to an abundance and generosity mindset. So I just want to take a moment to say that. Okay, so for today, I'm going to give you an introduction to the current climate around embodied carbon and circularity principles in the built environment. Then I'm going to break it into three different parts. The first being where embodied carbon and circularity meet. And then part two is the net zero by 2050, creating the most impact with 25 years to go. And then the third being rethinking carbon offset. So a little bit of fun, like a short section just to kind of think out of the box there. Okay, so production of carbon emissions is a global phenomenon. And while cities take only about 2% of the Earth's landmass, they are responsible for 2/3 of global carbon emissions. And rapid urbanization is increasing global demand for resource and materials, as well as for affordable housing and infrastructure, placing pressure on the construction industry and its supply chain. And unlike operational carbon emissions, which can be reduced over time, with the building energy upgrades and the use of renewable energies, embodied carbon emissions are locked in place as soon as a building is built. And so that means that in the near term, reducing embodied carbon is critical. And further breaking that down, looking at the whole building life cycle, upfront carbon is emitted before a building is operational and can significantly outweigh operational carbon. So the majority of a building's total embodied carbon is released upfront at the product stage at the beginning of the building's life, and that's A1 to A3 and including A4 and A5. But I'll kind of get more into some of the gaps there later on. And some tools and strategies to reduce embodied carbon broken out in a report, Embodied Carbon 101, released by the Carbon Leadership Forum last year, include build less and reusing more, designing lighter and smarter, using low carbon alternatives, and procuring lower carbon products. And so we've been developing clear strategies that can help people better understand the interventions they can make. Okay, so now let's talk about waste. In Canada, the built environment is one of the largest consumers of raw materials and energy, and is also the largest contributor to the waste stream by weight. 3.4 million tons of construction material are sent to landfill annually, representing an estimated of 108 million metric tons of embodied carbon. I know people like to compare things to vehicles and driving, so I looked into that, and that is the equivalent of over 7.3 billion kilometers driven by an average gasoline-powered passenger vehicle. That was using the EPA calculator. And demolition is still heavily practiced because these buildings were not designed for disassembly, and so it makes demolition the quicker, more simple, and more convenient option. But typical mechanical demolition is dirty, wasteful, costly, and poses health risks. So we haven't quite figured out how to enable and encourage and support deconstruction and reuse of materials so that we can drive down product and upfront carbon emissions and reduce waste. And something I've noticed over the last few years, I feel like especially in the last year in some conversation, is it's becoming clear that the term circular economy is sort of perceived as just more jargon in the sustainability realm. And I want to help people better understand what it means. And so a circular economy is one that is restorative by design. And it aims to keep products, components, and materials at their highest utility and value at all times. It's a global economic model that decouples economic growth and development from the consumption of finite resources and focuses on effective design and use of materials to optimize their flow and maintain or increase the stocks of technical and natural resources. So a circular economy would provide new opportunities for innovation across fields and establish a framework and building blocks for a resilient system that will work in the longer term. And so what does that look like in the built environment? Well, I'm sure many of you have seen this, this triage, this inverted triangle. And really what it's meant to do is persuade people to implement strategies that have the highest and most meaningful impact. You know, sometimes I think we've really started from the bottom, minimizing waste, but this kind of challenges us to think of it from the top down here in these strategies of building nothing, building less, building clever, building efficiently, and then minimizing waste. And this presentation really zeroes in on this strategy around building clever. I think it's a nice, let's meet in the middle here, you know? And so the situation we're here with right now is that construction and demolition, as I mentioned, is making up a significant portion of the waste in landfill, roughly about a third of the waste in landfill. And that of that waste, it's seen that roughly 37% of that is valuable lumber. That's here in Metro Vancouver, I should say. And this graphic shows that 40% of that comes from the residential homes. I've combined there the single family residential, multifamily residential, but just over half of that, if you look at that, is single family residences. So a standard home weighs close to 50 tons, and far too often usable resources are discarded at the expense of customers. I know many people who've seen demolition sites and just want to cry. I'm one of those people. So this is another great, some stats that came from the Lighthouse's report, opportunities of challenges of and challenges of deconstruction. And it shows that 43 metric tons of carbon dioxide equivalent is coming from over 177,000 kilometers. So that 43 tons of carbon dioxide equivalent, I also wanted to just show the equivalent to driving again. That's over 177,000 kilometers of an average gasoline powered vehicle. That's like driving from Vancouver to Ottawa 40 times, which would also be 72 days of driving. No thanks, right? And so that's a lot of emissions. That's just looking at 2,600, not just, but that's 2,600 single family homes that are demolished, 100 tons of material waste, and that could cost 112 million for Vancouver landfill closures and post-closure costs. And we've seen, this is from an article in 2015, that this heritage house ended up being demolished. And fortunately, since then, we're starting to see some introduction of some deconstruction bylaws. So City of Vancouver has the Green Demolition Bylaw in which deconstruction requirements applies if you demolish a heritage house listed, or a heritage listed house, or a house built before 1910. And since then, the District of North Vancouver has released a bylaw requiring deconstruction of homes before 1950, and City of Victoria released the bylaw that requires deconstruction of houses built before 1960. So there's more to each of them. We can't get into the details really, but they also include salvage, recycling, diversion rates. And so it's great to see that we're seeing the introduction of these policies that require deconstruction. Although I would hope that we can start to see more of this, and that the requirements do not only prioritize homes that are built over 65 years or more or older, because we know that a lot of newer homes built since then tend to come down sooner when people want to do these larger renovations or retrofits. Sometimes they just lump in a big renovation. And so what more can we be doing to optimize the reuse of building materials? Now, when it comes to policy around embodied carbon, we're seeing right now that the City of Vancouver has been putting a lot of effort in developing embodied carbon requirements that they're introducing in the Vancouver Building Bylaw 2025 updates. And this is proposing that all new Part 3 buildings will be required to model and report the whole building life cycle assessment and demonstrate a 10% reduction as specified in the embodied carbon guidelines. And so part of that 10% reduction, 5% can come from industry leadership credits, such as reporting additional emissions like mechanical, electrical, and plumbing systems, interior finishes, construction site activities, and transportation to site, as well as leadership credits for reusing materials and biomaterials. So you heard that right. This is great, because when I gave this presentation back in a year ago at the Build Reuse conference, I was addressing the gap between embodied carbon and deconstruction policy, and how it was interesting that embodied carbon requirements are being proposed for larger buildings, but salvage and deconstruction were for smaller buildings. So I want to shout out City of Vancouver for including this, as it really shows how those two goals are interconnected. So let's get into part one now, where embodied carbon meets circularity. And with that, I'm going to give this introduction or high level just overview of these circular strategies. So we'll start with deconstruction and material reuse. Here are some photos. Thanks to Vima Deconstruction for sharing these. I also have some from Brad Guy, who some of us took the BCIT Applied Circular Economy and course at Zero Waste Buildings, and we had a nice presentation from someone who was showing us some photos from his own home, which were deconstructed and reusing materials. So reuse of existing buildings and or materials will reduce emissions often by as much as 75% compared to demolishing and building new. That's from an RMI report on driving action embodied carbon in buildings. And while it might not always be possible to reuse an existing building or use a substantial amount of reused materials, the possibility is often never explored early enough in a project cycle. And taking time to establish whether a building and or material reuse is viable can have substantial embodied carbon and cost payback. So keep in mind here, though, that I'm not trying to paper straw this. So I think about the analogy of when, we're trying to reduce plastic use and we're using a paper straw in a plastic cup and the straw is not functional. We're not saying let's use materials that will not perform the way we need them to perform. And I want to talk about, the barriers right now to reusing wood is coming from the need to denail lumber, which is a timely process and requires space to do that. And it also, if we want to reuse those materials in structural applications, the lumber will need to be regraded. So the good news is that there are people out there that are working to develop tools that can streamline and simplify this process, such as Urban Machine. And that's a company that has this machine that if you feed the lumber through it, it can clean and denail it. And it's still in its early stages of development, but I know that they're also working towards having the machine regrade lumber. And so I think, they show some really nice photos. When this is PDF, I've hyperlinked that Urban Machine project inspiration to their lookbook, which shows different applications for how they're reusing lumber. And they just have some really beautiful applications. And I included interiors because that's really connected to part two of this. The other strategy that we're going to talk about today is design for disassembly. And so in design for disassembly, that involves choosing reversible connections that tolerate repeatable and assembly and disassembly, designing the building with whole lifetime of the building in mind, choosing materials with properties that ensure they can be reused, designing a simple building that fits into a larger context system. So that means prefabricated or modular systems, and as well as creating a plan for construction, design of the building, and deconstruction. And that would ideally include developing a material passport for your project. So over the lifetime of the building, this could save the owners a considerable amount of money and would really show that we're valuing the materials beyond the building's use. And this image here, I thought I would show it as well because this is the 6 S's, so site, structure, skin, service, space, and stuff. And it highlights that some of the building components require change faster than others. So if we think of the elements of a building as a series of clocks ticking down towards their required replacement, before I go there, we can plan construction and embrace this and optimize the design to allow for disassembly and adaptability. And so now thinking about the relationship here, my 7-year-old drew this. Just kidding, I did that. So this is really just showing that limitless possibility of where this Venn diagram of where these two things interconnect. And it means shifting away from that perspective of the linear thinking and realizing reuse potential. This requires that mindset shift, that behavior change, the cultural change, the systems change that we really need to be looking outside of just the boundaries of our buildings as shown here, to end of life, but actually thinking of it more circular and thinking of beyond the building life, looking at the benefits and loads of that life cycle embodied carbon. So how does material reuse and design for disassembly impact upfront embodied carbon emissions? Well, some of you might be already sold on these ideas, but not everyone is, right? And fair enough, people want to see the data. But where the gap is right now is there's not a lot of data right now telling us what we need to see to make the business case for this. So what we need to do is fill that. We need to be looking at how if we implement deconstruction, reuse, design for disassembly strategies, how does that impact the upfront carbon, embodied carbon compared to that status quo? When we're reusing existing buildings and materials rather than building new ones, we know that we can significantly reduce embodied carbon. But then how about the use stage? Building renovations generate significantly lower emissions than construction, typically 50 to 75% less than new buildings generate. So if we think about that and we think about how we're improving and measuring all of these strategies of making that building adaptable, if there needs to be a repair, it doesn't mean that we're going to have to really do too much to disturb the building and waste materials in that process and be more, able to disassemble things in a way to keep the materials, most of the materials intact. And then, of course, to what degree are these strategies going to impact end of life? And I did put in here that, right now we consider this stage as end of life, but this mindset shift also needs to happen where we don't think of it as end of life, but rather end of use, because these materials can continue to live on. So to what degree of embodied carbon could be achieved? And I know right now we're focusing on wood a lot because in this region we see a lot of, as I mentioned, wood in these landfills. And there's been conversations about biogenic carbon needing to be reported separately, and I think that's a very fair, we won't unpack that too much, but I'm wondering if we start to see intentional design in which we know that this building designers have done whatever they can in their means to make that end of use scenario to be reclaiming and reusing it. Does that mean that we can start to actually consider biogenic carbon, at least in the upfront stages? Is it more meaningful there? So just some thoughts with that. Okay, and that would mean that we're looking beyond our life cycle emissions, beyond the end of use. So now for part 2, we have this net zero by 2050 target, and what can we do? We have 25 years left to go. How can we create the most impact there? So typically when we talk about embodied carbon of a building, we're talking about substructure and envelope. And this is the structure and envelope scope. It's the most often used for LCA submissions. So this is not really giving us the whole picture, though. It explains why a lot of the focus is, but it does explain why a lot of the focus is given to reducing embodied carbon in structure. But this means that we're currently overlooking the embodied carbon associated with other building components like mechanical equipment, interior partitions, interior finishes, doors, lighting, landscape. So these items, if we were to be capturing them, that would mean that we're looking at the full scope emissions. And the reason why we don't really include this data is because there's a lack of it. So the more projects that request this via specifications, the more the suppliers will get on board with calculating the material emissions, or so at least we hope. But we, kind of building on that, we still don't know the full scale of carbon emissions from interior materials. We know that the initial upfront impact of new buildings could be up to 370 million tons of carbon dioxide equivalent per year. And I know I'm switching between metric and this is imperial here, so forgive me for that. But what about interiors? So one thing I wanted to say that is we have to continue to prioritize filling these gaps, which would include measuring data and embodied carbon emissions of MEP systems, furniture, finishes, and equipment, novel bio-based materials, materials and interiors. And just shout out, like kind of referencing again, City of Vancouver, we're really hoping that this approach they're taking for the leadership credits will start to incentivize industry to begin capturing and reporting this data. So we know a lot of that is upfront, but you know, a question I have is, are we underestimating the embodied carbon emissions related to replacement and maintenance? Because in those stages, we tend to just think of a new project instead of thinking of this existing building's operational emissions. So again, referencing this here, remember, if we think about the timeline of these layers, we can plan construction to embrace this and optimize the reuse of the building and construction materials, allowing us to divert waste and reduce embodied carbon. And the urgency of reducing emissions between now and 2030, or even 2050 for that, you know, specifically here, is it represents the time value of carbon, and that these strategies are critical to helping us reach our decarbonization goals. And, you know, I'm showing these layers because facade, but even like systems, partitions, and the things in there have more in that range of where we're going. That 25 years, that's in there. So let's, you know, can we achieve significant reductions if we're designing for disassembly, and if we're designing with reused materials that have that have a shorter service life. And so based on the, you know, this is another, I guess I didn't put it in here, but this is from also the Blueprint for Change, Lighthouse's report. And it projects that, you know, 10,000 single family dwellings are going to be demolished in Metro Vancouver over the next 5 years. And when I look and reference their previous stats that I showed, and I kind of do like some linear calculation there, even though I'm talking about moving away from linear thinking. But anyways, this, if I look at that, this would be the equivalent of over 165 tons of carbon. And if I'm trying to be conservative and we can only salvage 25% in terms of embodied carbon, that's still over 40 metric tons of carbon dioxide equivalents. So there is so much potential, and this is only looking at single family dwellings. So what if we start capturing those larger buildings that I also showed previously and just try to deconstruct whatever we can? Because one thing I will say also is it really gets in our way if we think go big or go home with this. We can still deconstruct some and see what the best we can do. So for this next section, part 3, rethinking carbon offsets, I want to keep it as short and sweet as I can, but I wanted to reference this. This is from the CAGBC's, the Canadian Building Council's Zero Carbon Building Design and Performance Standards. So when new projects, new buildings are pursuing zero carbon in design and performance, it's a balancing act. They're looking at the embodied carbon plus the operational carbon minus the avoided emissions. And that those avoided emissions include exported green power and carbon offsets. So exported green power often comes in the form of renewable energy credits, like purchasing RECs. And carbon offsets usually are achieved by purchasing offsets from projects that actively remove carbon dioxide from atmosphere, like reforestation initiatives. Before I move on, I want to say that why I show this is one of the barriers to getting owners, getting designers to really start to, you know, opt into applying design for disassembly in the way that they're approaching the design, or taking the time to find materials to reuse in their projects, is they see this like additional upfront cost to figuring this out. But where I want to sort of push back on that is to say, if we're serious about, you know, if you have a client that's serious about this and is actually pursuing the performance standard, they're also having to put some capital into purchasing the offsets, okay? But there's a lot to be said about carbon offsets, and we can't really get into this too. This is a whole webinar of its own. But there's a lot of criticism around the legitimacy of them. It's constantly being challenged and under scrutiny, which I think is fair. And some critics will claim that the whole thing, you know, does not really have any real bearing on health of the planet, or the last part, you know, so, or at least trying to be gentle with how I phrase this, like carbon sequestration offsets projects are the least effective. So defined as the long-term storage of carbon in plants, soils, geologic formations, and the oceans, and realized through activities including afforestation, reforestation, improved forestry, improved agricultural practices, and revegetation. So for every 1 ton of carbon that is emitted, we would need 1 ton of carbon that is sequestered, which would result in your net zero emissions. But one of the most popular carbon offset projects involves planting trees. So that could fall whether that falls under afforestation, if it's new area that wasn't previously had trees, or area with trees, planting there. People say it's a simple action to take and one of the most well-known ways to protect our environment. However, it's not, what some critics will say is it's not an effective way to reduce emissions in the long term. So let me see here. So if we're trying to, offset, to offset even a fraction of our global carbon dioxide equivalents, our emissions, we would have to plant and protect a massive number of trees for decades. And a newly planted tree could take upwards of 20 years to capture the amount of carbon dioxide that carbon offsets programs are promising. So there is always risk also of droughts, wildfires. We're seeing so many, tree disease, deforestation, wiping out newly planted trees. So in short, there really is no permanence there. And so this is like the out-of-box thinking I'd like to just have fun playing around with. But what if we created a model similar to renewable energy credits? Like, I don't know, we can call it something like in the lines of material reuse credits for the projects that did their best to implement embodied carbon reduction strategies into their projects, but still have to balance to offset, or still have that balance to offset. So maybe they are funding the infrastructure that can enable the deconstruction and reuse. And, which in large part, as I tried to include some graphics here, is the storage piece. Right now, that whole piece I mentioned earlier of denailing, sorting, inventorying, you can't really do that on your site. We're really limited in space. That takes time, that takes effort. So the storage is a big gap here, and we need to find a way to support that. So this has the potential to simultaneously simultaneously incentivize people to design for disassembly, as they might see that there's a future for those materials and they will still hold their value as deconstruction will be more feasible and supported. And right now, people don't see deconstruction as cost effective. But my question is, can we redirect funding that is still going towards fossil fuels and redirect that towards subsidizing material recapture and sustainable, equitable, and resilient urban mining? And start really thinking about that circular economy principle as, products as a service, or in this case, buildings as a service. So for my final takeaways and reflections, I want to just acknowledge, thanking you, if you made it this far, because I know this presentation has this energy, or I have this energy, I should say. But, to recap, today we talked about the interrelationship between embodied carbon and circularity. And, I highlighted these 4 points, but the focus for today really, I think, zeroed in on the build less, reuse more, design lighter, and smarter. And we discussed the time value of carbon and how deconstruction, reuse, and design for disassembly, if implemented and captured in the emissions reductions of interior finishes, could help us achieve greater embodied carbon reductions. And we wrapped up with some fun out-of-the-box thinking when it came to carbon offsets. But here are some few more reflections to take with you, that I ask you to take with you after today, is how can we continue to align the Part 3 and Part 9 embodied carbon and deconstruction policies? And can we create bylaw that requires design for disassembly? Can deconstruction of existing buildings and design for disassembly of new buildings be advanced at the same time? And a little bonus reflection here is, if a cradle-to-cradle or a circular building standard was created, applied, and achieved, could upfront biogenic carbon sequestration be included in whole building life cycle assessment? So I want to also just tie this back to why does this all matter? Like, why are we even here talking about this? And it's because embodied carbon is directly linked to public health inequity. And a circular economy aims to move away from an extractive economy to a sustainable and regenerative economy. And the principles of a just transition and the work of climate justice movements reinforce that idea that addressing climate change and equity cannot be done in isolation. The transition to a low carbon future itself must be equitable and create space to focus on new structures of power and accountability. And embodied carbon is inherently connected to climate justice and issues of public health and equity. I think I said that, but I'll say it again. And the topic of embodied carbon, for some of you who are maybe new in this, in this space, it can seem highly technical, but project teams can get started by pursuing interventions and implementing these intuitive circular strategies to reduce embodied carbon. But these strategies are not mutually exclusive, and a combination of interventions can result in deeper reductions than pursuing just one. The last thing I'll say is we'll have more decarb lunches that go beyond just the theme of circularity. But the next circularity themed one, pleased to share that it will be delivered by Lighthouse. So by Shiji and Adrienne at Lighthouse, they were going to talk to you about life cycle assessment of relocated and retrofitted homes. And in that presentation, they will highlight the environmental impacts of demolition in Metro Vancouver, and they will advocate for the home relocation and deconstruction as sustainable alternatives to reduce embodied carbon, material waste, and landfill impact. So I know that this presentation, we didn't really get into like the numbers, but for theirs, you'll start to see some of that embodied carbon data. I want to thank you all. And, I just want to thank like all of this information. There's, Sheila mentioned at the start that people have been talking about this since, what did you like, the 92 or something, So I just want to say that, or somewhere in the 90s, okay, when high-rise jeans were still acceptable. And so, or low rise, I mean, were acceptable. High rise, let's bring that. But so anyways, I just want to say, that the build reuse community has been a really big support, and I've gotten a lot of information from them. I'm also, the Structural Engineering Institute has the Circular Economy Working Group. And so, just a lot of great leadership. I wish I had like a rolling credits of people I want to thank for all of the work that you're doing in this space. And I think a lot of this is being in the right time and right place, and we have the momentum and we have the answers. Like, data is important, but we know what we need to do. We don't really need to keep spending all the time doing that, but I understand that for some people, the storytelling includes the data, and so it's a part of this. So thank you for being here. Let's open it up to the floor for some discussion and Q&A.
Thank you so much, Stephanie. I'm going to jump right into things. There's been a lot of discussion in the chat, kind of back and forth. Not as many questions because they're answering themselves and folks are throwing resources in, which is always great to see. But I'll kick things off with one question that was directing towards, like, do you see companies interested in insetting instead of offsetting? Is there anything that you can draw on that makes you quite optimistic about maybe this quirky idea that you're presenting that maybe isn't all that quirky? Because I think it makes a lot of sense. So any thoughts on that?
Yeah, thanks for that question. So, what I'll reference is, so we have the Near Zero 2 program that's to look at Part 9 buildings, reducing emissions. And it's a Vancouver program. And we're getting feedback from people in the program, what their interventions are. And we're seeing that, in some of the like community of practice conversations we've had, I've been hearing them give feedback about how they wanted to deconstruct and they want to reuse materials, but often that challenge is the storage. Like, where do these materials live until we're ready to use them? And then designers are spending all this time talking about embodied carbon reduction, focusing on the upfront carbon, and they want to reuse materials. But again, that infrastructure is not supported, it's not available, it's not reliable or convenient. And so I would say that to me is what like drives me, and actually it's exciting to see and keep hearing that, because it tells me they do want to implement this. They want to inset rather than offset. But that's why, you know, a lot of people talk about policy is like one of the key things that sort of raises the bar. It sets the new standard instead of making it like, oh, well, this consultant that we pulled in is spending extra time, and so their fees are higher, their consulting fees are higher than a competitor who's not pushing for these strategies that nobody is really requiring. So I think it tells me that people want to do it. They just need more support from policy. We need capacity building around teaching people how to deconstruct, as well as teaching people how to design for disassembly. We also need to find a way to harmonize this like physical infrastructure with a digital infrastructure around helping to move and connect people with these materials that they're looking for. And then, of course, I'll say it again, that storage is number one in how we start to like make the space for where these materials live.
Thanks, Stephanie. I'm gonna, Natalie, I'm jumping in now too, as we're sharing some of the question. I'm gonna go way back up to where Roberta Pecora, was one of our hosts and probably the most enthusiastic person in chat, mentioned that I heard it's pretty hard to even get the permission to demolish a heritage home or building. And if you could, Stephanie, maybe, talk a little bit about the Heritage Conservation Act now that you're onto policy discussion, if you can. Yeah.
Oof, I think it's hard to say, because right now, yes, it's harder to deconstruct the heritage homes. I might be a little bit behind in like what's been changing in that space, because I heard that there might be some changes with what's considered heritage. Don't quote me on that, but that I just feel like I need to do a little bit more like catching up on that conversation. But I think I was recently talking to Carly from, she's living in Hamilton, and I don't know, Carly, if you're in here today, but she is with the I'm blanking now,
Carly
but
Connor.
Carly
And
O'Connor.
yeah, so
There,
Green
Carly.
Salvage Materials and Recycle. Yeah, she's here.
Carly, can I like pass to you? Because I know we just had a conversation and you talked about how using the language heritage was like preventing people. It was like an icky word to folks. And as soon as you talked about embodied carbon and sustainability, people started to get on board with deconstruction. Do you want to like expand on that?
Yeah, I think, hi, I'm Carly. I'm chair of the advocacy committee for the Canadian Association of Heritage Professionals. And really we now call ourselves like in the sustainability spectrum, but we only got there because we've been reusing buildings forever and reusing materials forever. But there were obstacles that we had in our field, and heritage was like the only way to stop a demolition. And that was something we really needed to unpack. And we were also trying to stop a demolition like way too late in the process. And also recognizing that a lot of our heritage legislation like has designated the really old buildings, but we haven't figured out all the other ones yet. To say what's a good building, like what type of building has another 100 years in it. I'm a structural engineer, so I'll look at just the building as is it a good building as the first question we should be asking. And then, okay, does it have cultural value? Here's the, like, what does it represent in the community? Here's all of these other things. And we're really needing to recognize, here's buildings that we need to lock in stone. Here's buildings that we need to like figure out how we adapt them for the needs that we have now, if they're an adaptable building. And then if they aren't, to say like that these are or like it doesn't have use, it's not a good building anymore. The structure's gone. It needs to be upgraded seismically, and you really can't do it. There's a way to preserve the materials, to say that's like material preservation. And then that's all integrated into what we do already. And that seamlessly connects to the embodied carbon and the circularity discussions of the material reuse in a really clear pathway of like how municipalities could kind of just go through these same thought, I'd say procedure processes that we have, and link up to the other departments, which is why on March 4th, we partnered with the Codes Acceleration Fund to really look at this, of how to bring existing buildings and energy code and embodied carbon and circularity to take a step back and look at the entire building and like what it represents from a carbon perspective to answer, is this a good building? And if it's not, okay, here's where, you know, the new building sort of energy code can sort of rule. And sort of here's this gray area in between that we need to look closer. And then here's maybe this, you know, huge area opportunity where the buildings can stay and we can adapt and we can figure this out. But embodied carbon is this ability to give the roadmap in between, to attach it to circularity and kind of have the pathway to like play around with what you salvage and deconstruct and what carbon you save, and then compare it to cost and sort of have the material preservation side sort of integrated, a sort of building preservation and then material preservation, and how to link it all together a little more fluidly.
Thanks. And I feel like that to me connects. We did talk about this when I was sharing that like rethinking offsets piece, because to me that preservation, like on your job site, is the interventions that can be made by the designers and contractors, and then that, you know, what needs to be salvaged and the I guess like the cost and time of doing that maybe can like overlap with that thinking of like the offset credits, right? That can go somewhere where either people are using it or there's a way to be paying into that as your offset. That's where my mind goes with it. But yeah, thanks, Carly.
I'll jump in for a third question that has been top of mind as of late, in that we have this insatiable demand for more housing, and that speed factor is sometimes, it feels like it's not particularly aligned with stepping back and trying to change a whole structure regarding circularity. But then on the other side, maybe at this time of great change in terms of how we build things quickly, does this actually also present an opportunity where circularity can be applied? Do you have any thoughts about how circularity and reconstruction, deconstruction, reusing materials, although there are some challenges with the complexity of kind of managing that change, are there also things to make you hopeful that we could do both?
Yeah, I do. I do think we can do both. And in fact, I try to balance myself. Like I don't want to be showing up to be too frustrated at this, but I think that there's a need for housing. But the way that we're approaching it is like, who is this housing for? I was just having a conversation with somebody who she's being evicted because of a project. I won't say which one, but a big development project. And to find somewhere in her community that she already has been living for years, and at the cost that she's already been paying, that's a challenge that this new housing is not, it's actually created a problem for her than actually making it easier for people who already have housing to have housing. So on one hand, it's like, what are we actually trying to solve here? Because we do need housing and we need to conserve materials, and we have plenty of materials here locally that can be doing this. And so on one hand, I think, yes, speed, time, it's important. People are needing to live and to have shelter and to have housing. But are we rushing for the wrong reasons? Who are we rushing for? Can we take a step back and think about what we're doing, how we're approaching this, the processes in place, the resources that we're using to be able to deliver and meet these needs? And so I would say that it can be done. We have the tools. We send people to space. We can figure this out. Like, I think we can do it. I think it just means that we need to sort of be encouraged and to be innovative, to think a little differently, and to, I know this is a cliche, but to bring down the silos and to start working together better, because we know in an integrated process, we need the designers to be working with the owners, to be working with this and that, but we need the contractors and we need the deconstruction contractors. And we need people like Carly to be coming in here and telling us what can be salvaged, how it can be used, where it can be used, and what you can do with the rest of this stuff, you know? So I think we got the tools, we know how to do it. We just need to be serious about it, I think, and start just believing that we've got everything that we need to know ready, and we just need to go for it.
Stephanie, that is awesome. And I think that the next thing I'll just say, there's a lot of chat specifically instigated by the conversation that started out at discussing interior renovations and fit outs by a number of people. And so the great segue now, and I want to throw in Natasha Denenhauer's comment too, just recently. I think that reclaimed materials could flow into decentralized, aka regional production, bio-based panelized construction really nicely. I think this is the time to talk about the low-hanging fruit of some of these retrofits, if you will, using this model and these ideas.
Yes, totally. Thanks, Natasha. Actually, that is so true. There are so many opportunities. I think the other thing I will say, but pull me back, Sheila, if I go on a tangent here, but like, you know, developers, I think when we talk in that triage of like build nothing, it scares people. It makes them think that like we just want to halt in a way that's like that is not really realistic in terms of like way we need to develop and continue to grow, but not thinking of growing outwards, but like growing inwards. You know, like what can we do with what we have to meet the needs? We have the resources. How are we distributing it? And when we talk about this like need to you know, this urbanization, this densification, and we see this shift away from the smaller dwelling units to the larger Part 9 or Part 3 residential or, you know, commercial or other institutional buildings, there's an opportunity to be taking this material, to be making panelized system with reused materials, or even, you know, I'll mention it more later, but we have a panel at BuildX this year where we're talking about even exploring the possibility of reclaiming wood and putting it into dowel laminated timber, like mass timber products. So we can also start exploring this. It does take a little bit of again, like some effort in thinking of our manufacturing, of the way that this entire process, but definitely when we think about the retrofits and you know, maybe I missed, like, did I answer that or did I miss something there?
I love where you went. Thanks.
Yeah. Oh, yeah. I hope I answered your question, Natasha. Yeah.
I feel like there's actually some talk in the chat as well about that piece about standardization. And I know ZEBx has been thinking a lot about that with Roberto's comment about Be Collective, the role of systems like manufacturing systems that legitimize the scalability of solutions. Because I think a lot of folks have critiqued maybe some circular initiatives because they're not scalable. It costs a lot of money to do a very different process every time. And so I wonder, you know, if you have any thoughts on that piece, like the example of panelized solutions that Natasha and Roberto also brought up.
Yeah, I mean, that's the thing. I mean, it makes me think about just in general, like the embodied carbon regulations and trying to put that to council and the concerns that people have, which again, I think are legitimate, and we need to be able to like show people that, you know, that it can be done without additional cost. And I think that right now, the reason why there's premiums or it's not as effective and it is more costly is we haven't reached that economies of scale yet. And I think there's this balance of like build and they will come versus like kind of like the top down, bottom up. And again, triaging it like the way that Build Clever met in the middle. Like I do feel like there's like a middle ground of like building the infrastructure and starting to support it before it's ready in a way. Before people are even asking for it, because then once they're ready, they're like, oh, wait a second, I stopped doing this because I wasn't exploring this because I thought like it's not feasible, but now it is. And I was reading, I have a tendency to start books and not finish them. So I started reading The Lean Strategy, and I remember it was talking about the telephone. Like people, like when the telephone was invented, people were like, okay, but I'm the only one with a telephone. Who am I going to call? You know what I mean? And so there's like a little bit of that balance of like, if you're the only one who's sending materials to storage or looking for it, then is it really built to that level of, you know, rushing people and having that kind of supply chain, you know, that momentum or that way of the flows that we need it to be scaled at? And so yeah, I don't know all the answers there, but I will say that I think that to some degree, we need to like build this out. I do have some visions of how this could look and how it could be done. I see it as being like a more like P3 public-private partnership project where we have little nodes of where these storage places can be that helps keep materials localized. So like in a deconstruction project, City of Vancouver, they have a place to send it. We sort it, we inventory it. If it's not used within a certain time frame, we're building an inventory or hearing from people who want to pallet or receive a certain amount or quantity. And then if it's not, so if it's not used locally, then maybe there's like a larger warehouse. So I do think that this is something that needs to be operated and maintained, not just like the infrastructure is built. I think there needs to be real intention and like strategic business models, like that, also that 10x business shift in the way that we approach this.
Stephanie, you've got a lot of great ideas in the chat, and a lot of people in the room who have a lot of great knowledge. If you had to, just to wrap up, a last question, what can everybody do tomorrow? What give us some advice. Tell us what we should be doing tomorrow to start down this journey that you feel is the right path for sure. Yeah.
I want to keep it simple and just say, keep talking about this. Keep talking about it and say that you want it, because for a long time, I felt like when I was talking about it, it almost seemed like I was the only one. Like I had a hidden agenda of why I want circularity, when it was just because I'm hearing about, like, I'm a structural engineer as well, my background. And I was thinking about sustainability of like, what does that mean for me in my role? And so I'm hearing people talk about it outside, like in the planning, the sustainability, in the architecture space, the, health and wellness and urban development space. And so really it's about, people want this. Use your voice, use your power in that way to talk about how this is a need and this can really help us achieve our sustainability goals. And, connect with people. See where like you don't have all the answers. You can't do everything. We can't do everything alone. It takes a village. And so, yeah, just talk and find your people.
I think that's a very heartening place to end the conversation. We can, I think in the chat, I've already had 3 people reach out to me about new webinars, webinar ideas. I think there definitely will be one on interior fit outs. There seems to be a lot of interest on that, but the circular conversation is not going anywhere. So thank you again, Stephanie, for bringing all this together. And Sheila, thank you so much for co-hosting with me today. It was a pleasure to have you. Thank you to everyone in the audience for joining us and staying active in the chat. Just wanted to take note that Zeke, our building decarb team, is going to be well represented at BuildX in case you are going. So come say hi and come to our sessions. Our next decarb lunch is going to be at the start of March. And I dropped the link in the chat, but you can always go to the BC Green Building Calendar and check out all of our great events and many of our lovely colleagues across the industry. So thank you so much again, and have a wonderful rest of your day.